Hi there. So remember that although tuples are often explained as immutable lists, and they are in a certain way, but I think they're in fact more appropriately defined as data structures. And that's how I really present tuples in my Python deep dive course. I do not try and present them as immutable lists. They're really more data structures. So what I mean is that often we use tuples as a way to group a certain number of related objects together, each of which have a specific meaning, not just a list of values. That happens, of course. I'm not saying we can't use tuples that way. We do. But very often we're using tuples to group together, different values, different objects that are kind of related with each other. And that's a data structure. And then often we use the same structure with multiple instances of that structure. So the named tuple class is essentially a little code generator that gives us the ability to combine the efficiency of tuples along with the ease of naming the elements of the tuple. Because if you have a regular tuple, then, if you've got something like this, results equals 1, 2, 3, well, sure, yeah, you've grouped those things together, but you really don't have much context for what they mean, right? And so this is where the named tuple comes in. It allows you to give those particular positions in the tuple a meaning, a semantic meaning. So before I show you the Pythonic way of using named tuples when you're returning multiple values from a function, let's just do a quick refresher on the named tuple. So the named tuple is part of the collections module. So from collections, import named tuple. And I'm going to create one called coordinates. So coordinates I'm going to use to hold together the latitude and the longitude of a map coordinate. So it's going to be a named tuple. I give it the name of the class that I want. So the name of the class is usually set also to the variable that I'm going to use to store essentially this new class that I'm creating, this tuple class, this named tuple that I'm creating. And usually we give it the same name, but this name has nothing to do with this name over here. But anyways, that's kind of the convention. And then you have to give it what are the field names of this particular tuple. And you can use comma separated, space separated. You can also use, I think, a list. Essentially, we're saying that this named tuple, this tuple, has two elements. So all these tuples are only going to contain two elements. They cannot contain more. And the first element is going to be called latitude, and the second element is going to be called longitude. So that's the named tuple. Now we can create as many instances of this data structure as we want. We could say London is equal to coordinates, and then we'll have to give it, and let me look that up. That's in the notebook that you can download. It's linked below. Okay, so that's the coordinates for London. So I can do it this way. Of course, one of the things that you really should do in Python, especially when you're dealing with things like this, it's like, well, is the first one latitude or is the second one latitude? And so every time you'd have to go back and check what's the position of latitude and longitude. Instead, just use named variables. So coordinates, and here I'm going to say latitude. So maybe I want to define the longitude first, and it doesn't matter now because I'm using named arguments. So I can give the longitude first and then specify the latitude. That's going to work just fine. And that's 48.86, like so. So this is the better way of actually using the named tuple, is assigning the values based on the names, not based on the positions, simply because there's less chances for making a mistake. Now, these named tuple instances, London and Paris, they're instances of the coordinates named tuple, and they behave like regular tuples because, in fact, named tuples inherit from regular tuples. So I can access, let's say, the first element of Paris this way. I can access the second element of London this way, and so on. And you can see that I basically got, what, 48.86. I didn't get the second value I defined here. I got the first value, right? That's in the named tuple, the latitude. So 0 was the latitude, 1 is the longitude. And as I said, those are actually instances of regular tuples. I can take a look as is instance. We can look at, let's say, Paris. And is it an instance of the tuple class? And the answer to that is yes, it is. So this is great. They behave like regular tuples. But now, because they name tuples, you can actually access the properties using dot notation and using the name of the field. So I can say London dot longitude. And you can see also that my IDE here, Jupyter, is able to tell me what are the possible values that I have. You know, if I just say dot and then tab, you can see that I can find the count, the index, and I have latitude and longitude. Those are my two custom fields. So maybe I want the longitude. And if I do that, I'm going to get the longitude for London. So this is very helpful because it gives me context about the values that are in the tuple, and also it eliminates the risk or reduces the risk of grabbing the wrong value from the tuple because I'm using indexing and I forgot that latitude is first or second. Actually, I don't even remember now. I've got to go back and say, okay, latitude is the first element. So if I want the latitude, I need index 0. Much better to be able to just type latitude and just get the latitude that way. So the point I'm trying to make here is that named tuples are an efficient way of creating small data structures that allow us to use names to both specify and read back the values in the structure. This reduces the risk of making mistakes for both reading and writing the data, and as I just showed you, it also allows IDEs to provide autocompletion. Now, one of the main benefits of using named tuples is actually when returning multiple values from a function. Because in Python, functions can return multiple values. Well, not really. They can only return a single value, but they can return a tuple. And that basically is multiple values, but it's inside a tuple. Hence why I consider tuples data structures. It's basically structuring different values into a single structure that gets then returned by the function. So let's look at this rather simplistic example because we don't need to do it this way, but I'm going to create this function called minmax, and it's going to receive a list, let's say, of integers. So this is just me using a little bit of type hinting, and it's going to return a tuple. Okay, I'm just going to say, hey, it's going to return a tuple. I'm going to calculate the min by saying take the min of the list. I'm going to calculate the max by taking the max of the list, like so. And then I'm going to return min underscore and max underscore, like so. So this is my function. So I'm returning, well, I'm returning a single value, but it just happens to be a tuple, so it contains two values in it, in that data structure. So if I call this function, let's say 1, 2, 3, let's actually just mess up, stuff, not put any particular order in the numbers. Then I can just say results equals min underscore max of L, and then I can print the results like so. Okay, so I get that. I got this tuple back, right? You can see this was a tuple. Now we could just unpack it directly, right? So we could just say min underscore max underscore equals and just unpack that. And then we can look at min underscore and max underscore like so. So we get that same thing. But of course, I maybe, would have unpacked this into the wrong order. Maybe max comes first and then min comes first. So every time, again, I call this function, I need to access the results. I need to go back and see which one comes first, min or max. So that's the problem with just returning a plain tuple from a function this way. So the more Pythonic way is to use a named tuple to do that. So I'm going to create a new named tuple called minmax. Well, that's going to be the variable name for it, for that particular minmax named tuple. So the name of that named tuple is minmax. And it's going to have two fields, min and max. And again, I could have used a comma for separation. Just going to use a space to change it up a little bit. And then I'm going to take the same function that I had before, like so. But I'm going to make a couple of changes. One is I'm going to say that what I get back from min underscore max is an instance of the min max named tuple. That's going to help my IDE with autocompletion. So when I get the results back from this and I type the dot, my IDE now should be able to tell me, oh, well, you can choose min or max. Of course, I have to actually return that. So I'm going to return min max, and I'm going to specify min equals min, like so, and then max equals max, like so. So again, I'm using named arguments to pass that to the named tuple. Okay, so this is very similar to what I had before, just a little bit of extra work where I had to create this named tuple and then I had to use that for the return value. But it's really not a lot of extra code, and it makes our code much more readable and also less risk of making mistakes, especially for the people that are calling our function, which could be ourselves in another module or 6 months later. So now I can take min max equals min underscore max. I'm calling the function, passing it L. And if I look at min max dot and I hit the tab for auto completion, you can see I've got min and max. So I can get the max, or I can get min max dot min, like so. And we get those same particular values. So use named tuples when returning multiple values from a function. It reduces the risk of introducing bugs, and it makes the code much clearer and explicit. Now, a question you're probably asking yourself is whether there is a performance penalty, and if so, how large? Now, again, just as a reminder, don't fall into the premature optimization trap. Don't start, trying to optimize every single line of code that you write because, well, it's going to make things run faster. You have no idea when you're starting off, or at least you don't have a very good idea when you're starting off writing, a script or writing an application, where things are going to get slowed down. What are going to be your bottlenecks? So don't try and write code to address problems that may not even be a problem in the first place, because usually when you try and optimize code, you end up making it a little bit more complex. So when I first start writing code, I write for clarity. I write for correctness of my logic and clarity. Of course, I don't make, egregious mistakes in terms of efficiency of the code that I'm writing, but I don't try and optimize it until I know that there is a problem here. So anyways, that's just an aside. So is there a performance penalty between named tuples and just using regular tuples? So I'm not going to type all the code here. What I'm going to do is I'm going to open up the notebook that you can download. I've got the link below, and I'm just going to show you the results. So this is the notebook that you can see in GitHub, and basically it's everything I've been talking about so far. And let's jump to doing the timings, which I think I started doing. So on this line, I'm importing the random module, and then I'm going to import time it. And I'm just going to do a min-max given a list, and it's just going to return the plain tuple, the min and the max. And then I'm going to use the named tuple variant return. So I'm going to create a min-max named tuple, and I'm going to return the min and the max that way. Now here I'm just generating a list. So I'm going to generate a list with X number of rows and X number of columns. I set the random seed to 0 so that whenever I regenerate this list, I end up with the exact same list. I don't want that to be a factor in my timings. And then basically I create, however number of columns are specified, I create that number of values in that list with random integers between -5,000 and 5,000. And then I create this number of rows, which is this number of lists inside my outer list. Okay, so basically it's a matrix of, X rows by X columns. So if we go ahead and just generate, let's say a 5 by 5, this is what it looks like. You can see 5 rows, 5 columns. So now let's define some code that we're going to call min-max and min-max named. All it's going to do, it's going to basically iterate through those lists, however many there are, the number of rows, and it's going to yield the min-max of that particular list. Min-max, of course, returns that tuple. So for each element of the list, it's going to yield back min-max. And then the same thing here, but it's going to use the min-max named version. Remember, the one that returns the min-max named tuple versus the one that just returns the regular non-named tuple. So if we go ahead and then say try it out, we can say list all min-max lists. You can see we get the min-maxes for each row. For all the lists that we created, we have created this series here of lists, this list of lists. And if we do the min-max named, we get the same results, except now it's in a named tuple, but the values are going to be the same. So now let's time using a named tuple versus a regular tuple for the function return value. So we're going to generate our lists again, but this time I'm going to make 100 rows and 10,000 columns. And then I'm going to time it. I'm going to run this 100 times using min-max, so basically using the non-named tuple version, and it took 1.944 seconds. And again, for doing the same thing, but with the named tuple version, took 1.986. So remember now, this is doing it for 100 rows and then 100 times. So that's quite a number of iterations, and as you can see, the time difference is very, very small. So looks like there isn't much of a performance hit in terms of creating the named tuples versus creating a regular tuple. Of course there is, but it's very slight. But what about reading the values back from the named tuple? Because in one way we have to use indexing with the regular tuple. With a named tuple we can use indexing, but we can also use the named approach using the dot name. So here I have got read values by index. So I'm going to basically use an index. So I'm going to get my min-max results, right? Which is going to be a list either of tuples or of min-max named tuples. And I'm just going to read those things back and I'm going to yield them back out. But I'm going to iterate through the results and I'm going to grab the first result, the min essentially, by looking at index 0 and the max by looking at index number 1. I'm going to do the same thing, but this time I'm going to use unpacking. So as I loop through min-max results, I'm going to unpack into min and max and yield that out. And then I'm going to do the same thing, but I'm going to use now, I'm going to be expecting a list of min-max, right? These will work for either regular tuples or named tuples. This will only work for a named tuple, for a min-max named tuple more specifically, because I'm going to use the names to basically get the min and the max. So this is all doing exactly the same thing. This case, we're using indexing. This case, we're using unpacking. And in this case, we're using the names, given that we have a named tuple. So let's go ahead and create our list. So we're going to generate our list of data. So in this case, I just made 1 row and 100 columns. And I'm going to get the results, which is going to be just 1 row. And I'm going to do just a large number of iterations, basically. And then the results named is going to be the same thing as results, except this uses the all min max named function, which is returning named tuples. So if I look at my results, well, this is all I have, right? I just have basically that single row because I only have 1 row over here. So in this case, I just wanted to run the test this way. And I'm going to now, however, loop, essentially repeat this thing of getting the value out of this named tuple 10 million times. So I'm going to do it for the standard tuple by index. So I'm going to have, essentially I'm going to be reading the results, which are standard tuples, right? And I'm going to read the value by index. Then I'm going to do the same thing, but I'm going to use the named tuple by index. I'm going to pass in the named tuple results to read the values from the named tuple by index. Then I'm going to do the unpacking with the regular tuple. I'm going to do the unpacking with the named tuple. And then finally, I have to do the by name, but only for the named tuple. I can't do that on the regular tuple. So if we run all this, and then we go ahead and run this, and then I print out all my timings, here's what we get. You can see that for a standard tuple by index was at 1.786 seconds. Now, keep in mind, this is for 10 million calls, right? 10 million reads, essentially. 1.786 seconds for a regular tuple by index, 1.751 for accessing a named tuple by index. Don't read anything into that the named tuple is faster. It's just, it's so close that no, named tuple isn't faster than a regular tuple for indexing or for access by indexing. They're both tuples. So yeah, it just happened to work out this way. If I run it again, I might have the reverse situation. But anyways, close enough that it doesn't matter. You can see, however, that unpacking was maybe a little bit better. Again, that's pretty close, over 10 million iterations. Named tuple unpacking was 1.8. Again, I'm not going to ascribe this to a real difference because, again, a named tuple is a regular tuple. So there shouldn't really be that much of a difference, if any. But you can see the name tuple by name. That one I would say is definitely a little slower, but really not that much. Over 10 million iterations, you can see that it's really not going to make an impact to your code and to how fast your application is running. You know, if over 10 million iterations, you only have a 0.3 second difference. So again, that's why I said, be careful about premature optimization. Yes, named tuples are going to be a little bit slower than a regular tuple. However, that's probably not going to be the bottleneck in your code. So don't sweat it. Use named tuples, makes the code more readable, more Pythonic. All right, thanks for watching. I'll see you in the next video.